important term is augmented matrix. In the case of non-homogeneous linear equation, non-homogeneous linear equation. Non-homogeneous linear equation means Ax equal to B. We have to verify that if it is consistent or not. So we need to verify the system, non-homogeneous system is consistent or not. To test the consistency of the system, require a new matrix. That matrix is called augmented matrix. We need to test consistency. So, we have to construct a new matrix for testing consistency. Such matrix is called augmented matrix. So, I will say the actual definition of augmented matrix. The matrix, augmented matrix denoted by A by B. So, A by B, which is the augmented matrix is obtained by placing the constant column matrix B to the right side of A. That means we have A11 x1 plus etc. A1 and xn equal to B1. A21 x1 plus A2n xn equal to B2, etc. An1 x1 etc. Ann xn equal to Bn. We have Am1, Bm, Mn. We have m equations and n unknowns. So we can construct a column, the coefficient matrix A11 etc. A1n, A21 etc. A2n etc. Am1 etc. Amn. That's a coefficient matrix. And constant matrix B is B1, B2 etc. Bm. So in this constant matrix we place its right side of this matrix. That means A11, A12 etc. A1n, Amn, Am1, B1, B2 etc. Bm. So this matrix is called augmented matrix. We placed an extra column in the coefficient matrix. Such matrix is called augmented matrix. Denoted by, okay. So by using augmented matrix, we can check the matrix is consistent or not. So I will say one theorem related to consistency. A linear equation or linear system of equation Ax equal to B is consistent if and only if, this means if and only if coefficient matrix A and augmented matrix A by B have same rank. So a relation related to augmented matrix. A linear equation Ax equal to B is consistent coefficient matrix if and only if coefficient matrix A and augmented matrix A by B have same rank. So in this matrix, we can write down the above equation in this form. Ax equal to B. A is an m cross n matrix. S is an n cross 1 matrix. B is an m cross 1 matrix. So A is a coefficient matrix multiplied by variable matrix. We got constant matrix. So we can write down the above equation in this form. Ax equal to B. A is a coefficient matrix, X is a variable matrix, and B is a constant matrix. So above system of equation we can write down the form Ax equal to B. Here A is a matrix, X is a matrix, B is a matrix. Here we can write X is a matrix, x1, x2, etc. xn. X is a matrix which is variable matrix. So, any vector x which satisfies in this equation Ax equal to B is called solution matrix. So, x is a variable matrix. So, we need to find out that variables. So, any vector satisfies in this equation, such vector is called solution matrix. So the X is a vector, a variable matrix which is a column vectors x1, x2, etc. xn. Which these x1, x2, etc. xn, these n vectors satisfies our above m equations. That we have variable matrix X. That variable matrix is a column vector which has a vectors x1, x2, etc. xn. That n vectors satisfies m equations. That matrix is called solution matrix. So we have m equations and n unknowns. A11 x1, A12 x2 plus etc. A1n xn. Similarly A21 x1 etc. A2n xn. So follows AM1 x1 etc. AMN xn. This B1, B2 etc. BM. So these m equations and n unknowns we can write down the form Ax equal to B. When these BIs, all BIs are 0, that means B equal to 0. For all BI 0 means we got a constant matrix C0, 0, 0. Then we can say B equal to 0. The system is said to be homogeneous system. System is said to be homogeneous system. For all one of the BI not equal to 0 for some I. That means B is not equal to 0. Such cases, constant matrix is not equal to 0, then we can say system is non-homogeneous. We write down m equations and n unknowns, we can write down the matrix form, that is Ax equal to B. That B is equal to 0, then we can say homogeneous system. B not equal to 0, then we can say non-homogeneous system. If B equal to 0 means all constants are B1, B2, etc. BMs are 0. then we can say homogeneous. So B, capital B not equal to 0 means sum of the BI not equal to 0. Sum of the small BI not equal to 0. Then we can say such system is non-homogeneous system. A set of values x1, x2, etc., xn. These n unknowns satisfies m equations. These x1, x2, etc., xn is called set of solutions of simultaneous equations. So we have m equations and n unknowns. So we need to find a solution. So we got x1, x2, etc., xn. So these unknowns we got means these unknowns value we got means that values is solution set of simultaneous m equations. So we have m equations and n unknowns. So we got a solution. So we can say these m equations may be a solution or may not be. Always exist, that is not guaranteed. Sometimes it is exist, solution exist, or sometimes not exist. So we can say a linear system may have solution exist or solution not exist. Solution exist means we got a solution. So that solution can be unique or more than one solutions. So solution exist means have solution. So solution unique means one solution or more than solution. More than one solution. More than one solution means infinite solution. Solution not exist means no solution. So we have m equations and n unknowns. So solutions have three possibilities. One is unique solution. Next is infinitely many solutions. Third one is no solution. So one of the three possibilities are possible. So we have m equations and n unknowns means unique solution or infinite solution or no solution. These three possibilities are exist. Solution system have one solution or more than solution means we can say system is consistent. If system have one or more than solution, then system is consistent. Otherwise means if system has no solution, such system is called inconsistent. So m equations and n unknowns means solutions can possible three ways. No solution, one solution, or infinite solution. System have solution, one or infinite.